So your lesson for today, or what you're going to be working on for today, is to take the data that you got from the temperature changes from the lab, either that you were in class for or that you watched, and we have to make sure that we fill in this chart and make this chart over here, and then also do the graph and the analysis questions. So I'm going to start with the chart here. Those of you who watched the video of the lab, you may already have this done. Those of you who have not, that did this in class, we didn't have time to make this chart. So what I would like you to do is pause the video here, take some time, draw this chart over this is data table number 2, key events. So what I have here is the 5 events that we talked about, and then in class I kind of had you guys label these or refer to these more as A, B, C, D, and E, just for sake of recording them down. All right, so for letter A, only solid water in beaker, the time or time frame. So some of these are just going to be a straight time. And some of these are going to be a time frame. So only solid water in beaker, meaning ice, that is going to be from time 0 to whenever you made your first letter. Like I put letter B here at around 1 minute. If when I was watching the online video, I specifically looked and it was 1 minute and 2 seconds, but you guys can just put it at whatever number that you wrote it in. So 1, 1.5, whatever. And then use that temperature there. Use your starting temperature for 0, and then use your whatever temperature it is at whatever time. So for me, I'm just going to go with 0.4 to 1.6 for my temperature, but my time frame was 0 to 1 minute. Okay. Now in the video, maybe you were more specific, like 1 minute, 2 seconds, because you can, pause, rewind, whatever. So if you get more specific, that's fine. The temp was 0.4 to 1.6. Okay. So that was the time frame that we saw only solid water or ice in the beaker. And there was some issues with the water melting before you were able to, once you put it on there. So that could influence your results a little bit, but just go with what you have best down there. All right, now letter B says liquid water first appears in the beaker. That's your letter B in class that we did. So that was at 1 minute. Okay. And that was at 1.6 degrees. So this number, the ending, time frame from letter A is the same as the instance that we need from letter C. And then C, only liquid water exists in the beaker. Again, by the way, if you were in class that did this experiment, these will not be your numbers more than likely. This is just the sample data that I use, so make sure you use your own numbers. So look for where you first saw when you saw only liquid water exists in the beaker. All right, so I recorded at basically my ice melting here at about 11.5 minutes, so 11.5, and the temperature was at like 26.3. All right, so only liquid exists in the beaker, so that was my time frame here was 11.5. That's when it started. That's when I had when my ice melted, and the temperature with that was 26.3. Okay. And then where does it end? It ends at letter D. So wherever you first start to see your water vapor form. And for a lot of us, that was probably around like between 60 and 70 degrees. Maybe a little bit higher for some of you, but for me, I wrote it down here at 15 minutes and 30 seconds. So I'll just do 15.5. So that was at 62.4. So 62.4 for my temperature. And again, you'll use whatever temperature you have. And then 15.5. So if you were in class, you should not have these numbers because there's no way yours would be exactly the same as mine. All right, and then letter D, you're just going to put that 15.5 or whatever you got, and then 62.4. And then the last one here is just a single time frame. So it's water begins boiling strongly throughout. So for this one here is about 25 minutes. Oops, yeah, 25. And the temperature was at 99.1. Okay. So that's how we fill out that chart there. Like I said, you'll have your own numbers unless you did watch the video online. Then you will have those exact numbers. Or right around there, actually. Maybe you decided to put it somewhere else. Okay, so for the next part here, you have to create a graph. And this one takes a little bit of time here. But let's set us up for everybody to have the same units and the same X and Y axis. So I'm going to start here on the bottom with our X axis. And we're going to do time on the bottom. Make sure that you put the... write down time, and then in parentheses puts the units, so it's minutes. All right, and then what I did was I started at 0. Put that one in. So 0, and then the most I can really go up to is 30 minutes, and I think everybody should be fine doing that. There might be some people whose time was much shorter in class, but I think just for sake of making everybody's the same, everybody should do every block is equal to 1 minute. All right, so we have 0, and then 5, 10, 15, 20, 25, 30. Now, just a disclaimer here. I don't know for sure how it looks on paper, but for me, I kind of see some of these lines that are like bolded, like you see where the 20 mark here, like this line looks bold, like a little bit more bolded to me. And usually you do that with every 5th line or something like that, so it marks off them easier. But it starts to do that, and then it doesn't. I have another bolded line here between these two, and there's only 2, and then it starts over again. So don't pay attention to those so much if you were looking at that. Just make sure that you are counting single boxes. And the same thing is going to happen when we do it on our y-axis. There is a little bit of a misleading, those bolded lines are a little misleading on our graph. Okay, so go up to 30 for your time. I said you might not fill that all out. So pause the video here if you're still working on that. Now temperature. Temperature was a little bit harder. At first I tried going up by 5s and had so every box essentially would be 2 degrees. So 2, 4, 6, 8, 10. But I only ended at 90 degrees when I did that. So if we go by 5s, our graph is going to be very, very small, like half the page. As far as height goes. So I decided to go with 4 as a unit spacer here. So every 4 boxes I went up 10. So again, starting here, go ahead and label your y-axis here with temperature, and then also make sure you put the degrees Celsius. So temp, degrees Celsius. And again, make these little hash marks on your lines when you do this. Do not just go and write 10 like this, because I have no idea. What is 10? Is it this one up here? Is it this one here? So make those little hash marks there. Now, for me, it was hard because I had to constantly keep zooming in and out on here, but I think for you guys, maybe you'll be okay because you have it on paper. The hardest part of this one is just getting used to the scale. It's not a 1, or a 2 scale. So, when you're looking at your numbers here and your values, this is going to be 5, this is going to be 2.5, and this is going to be 7.5. And so depending on your temperature, it might be easier if you see it like this rather than, if you can do it in your head, that's fine too. But I know that I kind of was like, okay, where do I put this again? What do each one of those lines represent? Now, I don't think you need to go ahead and label every one of those, but, maybe especially for maybe the starting numbers because they got so close together, maybe you do that. But I'll leave that up to you, okay? So once you have, and it would be the same up here. So this would be 12.5, this would be 15, this would be 17.5. You know, so maybe at the very least you just label like the 5 marks there. You know, something like that. Maybe that is a little bit easier to when you're doing your graph and trying to find your numbers and your values. Again, don't pay attention to the bolded lines. They're not going to, you know, line up with what you have down for your dashes there. Okay. So then after that, it's just a matter of plotting. And as you can see, you're going to have lots of plots, you know, upwards of about, you know, 40 to 60. And what I want you to do is just do a dot system like this. I don't want you to do a line. I just want you to do a dot system like this. So you can use a different color if you want. Otherwise, pencil is fine. And then I have heating curve of water up there for the title. All right. And then under the analysis questions, so it says as time went on, what was happening to the temperature of the water? You should be able to answer that. At what temperature did you first see liquid forming? Again, it should be in the low single digits there. Think back to concept 2 when we learned about physical properties. What is the temperature you listed in number 2 called? So when we're talking about, I think with that one, what we're talking about that is like average kinetic energy. So what is the definition of temperature? And then what temperature did you first see steam? What temperature? Oh, sorry, never mind. Number 3. What is the temperature that you listed in number 2 called? So let's see. Oh, that just is the melting point there for number 3. Sorry, that's kind of maybe worded really weird. So it's the point at which we first see liquid forming. All right. So then that should help you answer number 5. So 6, you should be able to answer 7. Okay. I think you should be able to answer that one. That's just back to your hypothesis. And 8, and reflect on what you observe. Okay. So this is basically just a conclusion sentence, and if your hypothesis was totally right, it can kind of be similar to that. I want you to tell me what is happening to the particles in water as far as their movement. Okay, what do they start out as when they're in a solid form? What is their movement? And as they go to a liquid, how does that movement change? And as they go from a liquid to a gas, how does their movement change? Okay, so how does their movement change between states? All right, so I think that should give you enough information to finish doing that. Change when you move to different states. Oh, one other thing I wanted to mention, and I think I might have mentioned this in class. We see some really kind of weird shapes going on here at the beginning. And a lot of you that were in class were asking me about that too, and I maybe didn't explain it to the online students or the students that watch the video. This is natural here. It's not what we want to actually see though, but this is right here is kind of what I'm talking about. This is what's happening because of the ice melting and the water heating at the same point, and just where the thermometer is in the beaker. So the thermometer is generally at the bottom of the beaker, and so it's probably it has more access to the warmer temperatures. But as the ice is melting, it's creating pockets of cool water. And that just continues kind of swirling around. So, at snapshots in time, you can see that it starts to look like it's getting colder as that ice is melting. So, like I said, maybe a little misleading there to see it's really just this hump right here. Really, it probably should have been like, if I'm going to make some dots here, I'll just do them in brown. It probably should have been like My pen's not big enough. You know, something like this. But that's our data. We can't do anything about that. But that, like I said, don't read too much into that. That's just natural from the effects of the uneven heating that takes place with that. All right, so please submit copy or scans of all of these pages, including your data and your graph and your analysis questions. So pages 22 through 24. Submit that to Shobi for your next class period.